Alright, before we get started, I want to explain what stat edit stat calc is with a little illustration here. So in your TI device, when you guys are trying to use stat edit stat calc for regression, you guys would hit stat edit, it's number 1, so you either hit number 1 or enter. This is where you guys would enter your data. So this column would be the x's, this would be the y's. If you ever need to clear, you would just hit clear and enter and everything would go away. And then you can type in your values again. Once you have stat edit taken care of, in between stat edit and stat calc, there's a middle step you guys should get in the habit of doing. You want to see what your points look like. You can see it over here already in this table right here, but that's not, you can't just see these in your handheld calculator. So if you want to see what your points look like, you need to go to y equals. You need plot 1 to be turned on. If it's not on, it's going to look like this. So to turn on plot 1, you're going to hit the up arrow, so it's blinking on plot 1. If you hit enter and scroll back down, it should be highlighted. So that will turn on plot 1. Plot 1 needs to be turned on anytime you guys are just seeing points. If you're trying to graph a line or a curve, it needs to be turned off. So make sure you're in the right setting, depending on what you're trying to do. And then if you guys want to see points, once plot 1 is on, you hit zoom 9, and that will show you what your points look like. Okay. Now, if you're done looking at the points, you want to go back, and if you're going to keep doing problems, that's fine to keep plot 1 on. But anytime you guys want to graph something else, like let's say you wanted to graph 2x minus 6, like a line or something, you need to make sure that plot 1 is off. And then instead of going to zoom 9, so any zoom that you use when you go back to graph, it's going to stay there. And so you can see, you can't really see your graph very well. So if you guys are going to graph anything besides points, you want to go to zoom 6, which is your standard window. It's going to reset. So use zoom 6 for anything besides points, but if you want to see points, use zoom 9 with the plot 1. Okay, so that's how you see your points, just to make sure that it's quadratic. So once you've confirmed it's quadratic, you've done stat edit. Now you're going to do stat calc. And because we confirmed by looking at points that it's quadratic, you're going to hit 5 for quadratic regression, hit enter, and then you have all this information here. And again, all you have to do for regression is plug in -1 for A, 3.2 for B, and 1 for C, and then just write it out. Alright, so we're going to start with the conversion. This little bit right here. So this side is going to be going from vertex form to standard form, and then this side is going to be standard to vertex. Again, you can tell that it's vertex form because it has parentheses. So this one's very operatic, very simple. You guys just FOIL and then combine like this. So it's really very basic with the algebra. Remember that when you guys, I know my signs are falling here, fix this. Whenever you guys have addition or subtraction inside of parentheses, you can't distribute a power. Okay. So by default, I want you guys to get used to doing this. Anytime you see parentheses squared, if there's an addition or subtraction inside, I want you to rewrite it like this. That'll keep you from distributing. If you make it so that it's not squared anymore, you just write it as multiplication. That'll help you avoid the mistake of potentially distributing. So anytime you guys see a binomial, which means 2 parts with addition or subtraction between, you see a binomial being squared, just write it twice. Use the definition squared. And so then when you guys are multiplying binomials, you guys use FOIL, which that's not the point, so I'm not going to spend time on what that is. When you FOIL, you would get x squared first, and then outer, inner, flat. So once you multiply the binomials together, you get this expression, and you still have -12 at the end. Once you FOIL, that's the first part, then all you have to do last is combine like this, and then you're done. So f of x equals, because this is our final answer, to make sure it's a complete function, x squared plus 2x minus 5. That's all you have to do. Just work out the algebra, simplify it, and then you no longer have the parentheses anymore because you multiplied it out to that side. Okay? So remember with this one, once you see this, rewrite it, easy. Don't do anything until you've gotten rid of this where you just rewrite it so it's being multiplied by itself. And then for this one, you need to be really careful with order of operations. You guys don't want to distribute the 3. You because if you distribute the 3 here and then FOIL, it's going to mess everything up. The 3 is supposed to be multiplied times this entire thing, so if you only multiply it to this one by distribution, then it's going to mess up the answer. So leave the 3, anything that's in front that needs to be distributed, leave that until after. So you're actually distributing it to both things. So we'll leave the 3 alone, and then when I FOIL first, outer, inner, left, what do we get when I FOIL? I'm actually going to neaten up the inside square to be 3. So the x squared minus 4x. Find my terms like that. And then once you have the FOIL taken care of, again, that should really be what you focus on doing first, is FOIL first. And then anything else you need to do, whether it's find my terms or distribute or anything, do that last. So I have f of x is equal to 3x squared minus 12x plus 12. It's very algebraic, it's just multiplying and then combining my terms. So hopefully that shouldn't be too big of a deal. You guys okay with that? Okay. The other way around though, this is the one that we're focusing more on. This is where you guys start in standard form and you're going backwards to vertex form. In order to write vertex form, what you need to know? The vertex. That's the whole point of the vertex form. So what we're going to do is we're going to find the vertex the exact same way that we did last class. We're going to find the vertex, and then once we know what the vertex is, which is h and k, as well as a, which is always the number in the front, plug those into where they would go in the vertex form. Right, but our first focus is to find the vertex. So how do we do that? Let's imagine I was to graph this. Like all the quiz from last class. What would you do to find the vertex? Negative b over 2a. Do a little formula for finding the x value of vertex. So because b is already negative 2, if I do negative b, negative 2, becomes positive. A is negative 1, so 2 times a is negative 2. So when I simplify that, I get negative 1. So my vertex, the x value of my vertex is negative 1. We're doing the exact same process as if you guys were going to graph this, just like that. And then how would I find the second value? How would I find the y value of the vertex? Plug it in, just like we did last class. So if I know that x is negative 1, then I'm going to plug it in. Like last time. So we have negative 1 squared is positive 1, but you're doing the negative of that. So it'd be negative 1 plus 2 plus 5, which is 6. So find the vertex the exact same way that we already learned how to do that. There's no new process here. We're just doing carrying over the same process. Once you guys find the vertex, you're now ready to write the vertex form. We're going to have f of x. If you guys remember from last class, vertex form looks like this. So all you need to do is plug everything in where they go. So what's a? Negative 1. You pull a from the original equation that we had. So a is still negative 1. That doesn't change between vertex and standard. Then you guys have your parentheses x. And then this value right here is what goes inside the parentheses. So what happens? Opposite sign, right? And then what happens to this number? So it's kind of like what we were doing with absolute value. When I gave you the picture of the absolute value and you were trying to write the equation, you found the vertex and you plugged them in where it goes in the equation. It's the same thing here. Once you find the vertex, this number goes inside the function, just like absolute value, but it changes sign. This number goes to the end, just like absolute value, without changing sign. Same kind of process. So again, find the vertex, use the thing A, and then plug everything in. That's the conversion process. Is that clear? Alright, let's try it again. So I'm going to use negative b over 2a. What's b in this case? So negative 4, what's a? So 2 times 1 is 2. So this is going to give me a negative 2. My vertex, that's the x value. Now I find the y. Plug it in. Negative 2 squared plus 4 times negative 2 minus 1. That's 4 minus 8, which is negative 4 minus 1, negative 5. Should I do that together exactly whatever? Once you evaluate this, that value, that output is your y value for the vertex. Is everybody okay with how we draw the vertex? Let's piece together the function. Remember, what's the value that always goes at the very front, regardless of whether it's vertex or standard? A. So you're going to have the same A, the A doesn't change. So what's the A for this function? 1. Do you guys write a 1 or just leave it blank? So straight into start. And then if my value here is -2, what would it be here? You can change the sign. This number is -5. This number changes sign when it goes inside. This number goes to the end. Don't forget your parentheses squared. That's what makes it quadratic as opposed to absolute value where it would have a bar. Make sure you guys, when you're writing quadratic, you have the parentheses squared. Alright, everybody okay with the conversion? And we're going to transition into our second concept for today, which is the regressions. So you guys would have learned, or at least heard of, line of best fit at some point in the past. Doesn't that give you like a bunch of random dots? You guys have to give you the equation of the line that goes through the middle. Best represents kind of like the average. We're doing stuff like that, except we're not going to be using linear. We're going to be using 4 different models. We're going to use quadratic model, cubic model, quartic model, and exponential model. So these 2 we're going to be learning in Unit 4. That's one I think is Unit 6 or 7. We're focusing on quadratic for today. So we will have all those different regressions and models under our belt by the end of the year. So there are 2 different mediums you guys can use. You guys use your handheld calculator, which is what we did last time with the stat edit stat calc, or you guys use Desmos. There are different benefits to either of them. This one's really important. You guys need to be fluent with the TI devices. You guys are planning to go beyond Algebra 2, college or in high school, like pre-calc or anything about that. They don't use Desmos, so you need to be able to use your handheld TI device fluently. So it's good to know how to work with that device. But Desmos has its own really cool benefits as well. Like in Desmos, as you can see in this little snapshot right here, not only will it give you the information over there, it also graph it for you in the same window, which is really helpful. You have to go to a whole different window, whole different process in the TI interior in order to get the graphics. So it's a really cool benefit of Desmos. But so this is what we talked about last time, the stat edit stat calc. In between stat edit and stat calc, I have step number 2. This is a really important step, especially when we get into Unit 4, where we're going to have 3 different options, quadratic, cubic, or quartic. You guys need to be able to look at the points to know what shape they make. If you have points that look like this, is that a U? No, that's that kind of swirly one. That would be a cubic function. So when we start getting into later units, you guys need to get into the habit of looking to see what the shape of the points would be, so you know which model to use, because the directions are not going to tell you which model. They're just going to say, find the regression. Okay? So just to show you how to use that extra step, hopefully you guys didn't clear anything and you still have some information in your calculators. If you guys go to stat edit, and just have some points in there, it doesn't really matter what they are. Stat edit, then if you already have some points in L1 and L2, you're fine. If you don't, just add a couple. Alright, to check to see what shape your points are making, you're going to follow this step 2. You guys are going to go into the y equals window. Y equals. Plot 1, 2, and 3 are at the top. You only want to turn on plot 1. So if you guys hit the cursor so that it's blinking on plot 1, and then hit enter and then scroll back down, it should be highlighted in black. That's how you know that plot 1 is on in your y equals window. Does everybody have that? Y equals, like where you're going to graph something, then hit the up arrow that's blinking on plot 1, hit enter, and then scroll back down, and it should be highlighted black. Okay? Once you have that, hit zoom 9. And you should see points on your screen. I don't really care what shape they make, you should just see points. See points? Okay. So in the future, when you guys have a bunch of points and you're trying to check what shape they make, that's what you would do. You would turn on plot 1 if it's not on already, and then hit zoom 9 to check out and see what shape. Okay. And then again, we talked last time with stat edit and stat calc 5 because it's quadratic. You guys will want to hit the number 5 button for the quadratic progression if it makes that U shape. And then all you guys have to do, I told you guys when you got to that screen yesterday, that information that was on your screen, how we would use it. In your screen, it would have had this function at the top, and then it told you A equals B equals C equals. All you have to do is take A, B, and C and plug them in, and then you have your model. It's really quite simple. You just have to remember how to use your device, and actually getting the numbers is pretty straightforward. Your calculator does it for you. In Desmos, however, I'm going to show you how to do it in Desmos. This picture right here is Desmos right with this example. This is what Desmos looks like. But I'm going to show you how to actually do it. So who actually does not have a TI device at home? If you don't actually have your own personal TI, whatever, 83 or 84, obviously you can't do anything that we're going to do in class at home, unless you have a sibling or you can borrow from a friend, or you can turn your phone into the TI-83, or you can get it on your computer. I think there's like a computer or something. I personally have a little app that lets me put it on my computer. I don't know if you guys have access on your computers. But if you guys don't have access to the TI, you just can't find any way to get it, then Desmos is your only option. I'm going to focus more on showing how the TI-83-84 works. I'm not really going to spend a lot of time on Desmos, but if you don't have access to a TI device at home at all, you can't figure out any way to do that, then you're going to have to work more closely with Desmos, and if we can help you do so. But anyway, Desmos, I recommend for anybody to try it out. So if you have Desmos here, are you guys familiar with Desmos, or is it like new? Anyways, instead of going to stat edit like you would in a TI calculator to create a table, you just hit plus table. Okay? Then you start adding things. So I'll just make up okay. So again, what's really cool about Desmos is that while you're doing this, you can see everything pop up in your calculator. You don't have to hit zoom 9. There, you have the graph and the table in the same window. You can see them. Okay, so once you guys have the points, you can kind of see how it makes this U shape, right? Now, instead of doing stat calc 5, it's just 3 buttons you guys have to push in your TI calculator. You have to type in this long, complicated thing. So you guys have to do Y1. When you guys hit Y1, it'll automatically go down to that sub position. Then this squiggle thingy. Then A, X sub 1, so X sub 1 squared, plus B, X sub 1, plus B. All that whole expression is in your notes. It tells you what to type out. And so once you type it out, that's all the information. It's all there. That's all the same stuff that would have come up in on your TI if you had hit stat calc 5, second step. This is the exact same screen. And again, what's really cool is they show you. They graph it for you right here. They show you what the vertex is. They show you what the y-intercept is. If it had hit the x-axis, it would have shown you that too. The little gray points are the vertex and the intercepts. They point them out for you. So that's what's really cool about Desmos, is that it gives you these specific points right there. You don't have to really go too far to find them. But that's how you would use Desmos. Typing this can be a little complicated. If you don't have a sub 1, messes it up. See? You didn't have a sub 1 for that one. It just totally messed it all up. So you have to make sure that you type it in correctly, otherwise Desmos is not going to know what to do. So I would recommend practicing both, see which one is good for you. You guys can use Desmos to check your answer if you're using TI, and you want to make sure that it's graphed correctly. You can use both and use this one to kind of check your answers. It's a really good strategy to use that way. Okay, so that's Desmos. All right. First one I want you guys to practice. See your calculator. Oh, I'm choking. All right. Go to stat edit and then enter those numbers, please. Remember that the L1 is the left column is all the x's, and the L2 is all the y's. So we have 0, 1, 2, 3, and 4 for the x's. 1, 2, 3. Right, so remember it's stat edit, stat calc, so do stat edit and enter your points in there. Then what? What happens after stat edit? Okay, so you guys can make sure that it actually looks quadratic. So if you guys hit zoom 9, you can see your points. I mean, you can see them on the screen here too with decimals. You can see the points like this. You can see them in you. So then after stat edit, you check your points. What happens next? Stat edit, stat calc. So now hit stat, then scroll over to calc. And because it makes that U shape, which one of these regressions do we want? 5. Hit enter. Alright, so now on your screen, you should see y equals ax squared plus bx plus c. And then you have a equals b equals c equals. Do you see that? All you have to do is ask you for a regression, which is what the direction says here. You're going to write y equals, and you're going to plug in a, b, and c. So what's a? So I'd write negative 1x squared. What's b? Plus 3.2x. And what's c? 1. You're just writing out y equals ax squared plus bx plus c, but instead of writing a, b, and c, you're writing what numbers they are, which is what the calculator or Desmos, you can see Desmos give you the same numbers. Just plug them in. And that's all I want. Okay. Nope. We will in a second. We'll see some application questions, but if I just ask for a regression model, that's what I want, that equation. Alright. So I'm going to introduce this. We're not going to have time to, I just hope the quiz is longer than I thought, so we're not going to be able to get very far onto the application on the next page. But these questions right here are extremely important. There are 3 things I could ask you about a regression. I could ask you to find the equation, which is what we just did, or I could ask you 2 different types of application questions. I could ask you to find a maximum or a minimum for your model. Now, because it's a quadratic, when I ask you to find the maximum or the minimum, what specifically am I asking you to find? What part of it? The vertex. So that's the most important thing to make a connection to. When I want the maximum or the minimum, I really just want the vertex. And we know how to do that. How do you find the vertex in standard form? How do you find the vertex when it's in standard form? There are no B's. I think you're thinking about vertex form. I'm not talking about vertex form. I'm talking about this is in standard form. If I ask you to find the vertex of this, how would you do it? The negative b over 2a, I think. Right? So if I ask you to find the vertex, you do the exact same thing that we were doing up here on the right-hand side. Use negative b over 2a to find the x, and you plug that in to find the y. So it's the same exact stuff we've been doing, it's just going to be hidden in the, it's like a word problem. You have to read the question to know that you're asking. And then the second kind of question I could ask you, I think it's also very simple, is to find the y value if I give you the x value, which is, again, very simple. If I give you the x, to find the y, all you have to do is plug that in. If I tell you what x is, and I want to know what the y is, you take the x, you plug it in here and here, take in your calculator, done. Okay? So only 2 different follow-up questions I can ask you. Find the max or the min, or if you know what the x is, can you please tell me what the y is by plugging it in. It would look like, so on the next page, I have 2 different questions. This is what it would look like, right? If you see a question, it says we have desktop computer purchases by household. We have a little chart here. Again, anytime you guys see a chart with data in it, think regression. I'm going to have to do stat edit stat calc. We want to find a quadratic model for this data, right? Now, when they give you numbers that are this big, right, these are huge numbers. 1,990, 1,995. Those are big numbers. Your calculator cannot handle that. Right? Your calculator can't handle numbers that are that big. So what you guys need to do is use this little key right here. Instead of typing in 1990, the year, we're going to type in 0. We're going to set 0 to represent 1990. We're going to use 5 to represent 1995. How do you think that would represent calculator can work with them easier. It'll still be able to find the regression model for us. We're just bringing down the numbers by a factor a little so that the calculator can recognize them. Alright, so now in your calculator, what's our process? What do? Stat edit. So everybody go to stat edit in your calculator. The x values are the first row here, and the y values are your second one, is the second row. So in your calculator, go ahead and enter those. This is a very hands-on. Everybody has to be doing it, or you're not going to understand. So everybody in your calculator, make sure you're doing the process. So 0, 5, 10, 15, and 20 are your x values. Y is the bottom. Those are reasonable numbers. You don't have to change like shrink them at all. Alright, so we did stat edit. Now before you use stat calc, what should you get in the habit of doing? Go to y equals, double check that spot 1 is on, and then zoom 9. And you'll see this nice little pop. Can we just confirm this is quadratic? Yes. Okay. So now we did stat edit. Now what? Stat calc 5. Enter. So I have a little screenshot of what should show up in your calculator if you did it correctly. Your notes. Once you see that, just go ahead and write down the equation. So I'm going to have y equals, and then what would I write for my first coefficient? You're going to round the third decimal. Go to the third decimal and round it if necessary. That's going to be, don't forget the x squared. You're just plugging in a, b, and c, but x squared and x are still there. And then how would I write the next one? 9, 4. That. And then c. Yep. That's regression. Everybody get that first part? Alright. Now, I have 2 follow-up questions here. We're going to figure out what they're asking us to do. This is where the word problem step comes in really here. This first one says, based on the model, so that means we're going to be using this equation. Based on the model, in what year were the most computers sold? What are they asking? The highest maximum. You guys see how this is a maximum question? What word gave it away? Most. And you guys see words like most, highest, lowest, least, coldest, hottest, whatever the context is. If you see an extreme word like that, it's indicating the highest point or the lowest point. That's a max versus min question. Now, they're asking in what year, so are they asking for the x value or the y value for this? So, like for any word problem, you guys want to highlight it, underline it, put little annotations in there. So the most means that we're looking for the maximum, and then we're finding the x value. So we're looking at the vertex, right? Remember we just said on the previous page, if you're asking for the max or the minimum of a quadratic function, it's always the vertex. So how do I find the x value of the vertex? I consider one. Negative b over 2x. Pretend that you're going to graph it. Negative b over 2x. How do I always find the x value of the vertex? Just like the last one. Now this is going to be a little bit weirder because they are decimals. So you can work through it. So b was the 3.794. I'm going to have negative 3.794 on top. And then 2 times negative 0.166. Okay, so what do you get? Total? Total. 11.43. Okay? Everybody get 11.43? Okay. Now, this is for x, right? But what did we do at the very beginning with our x values? We shrunk them, right? We don't want to say year 11, right? We need to convert this back. So if we're saying year 11 and 1990 was 0, like what year would that be if we converted that? 10 was 2000. So what would 11 be? 2000. When you do that conversion, make sure you unconvert it to get an answer like this for an application. Everybody see how we did that? Alright, next question. Use the model to estimate the percent of households with computers in 1998. What do they want to know? They want to know what is percent of households. The Y given a year, which was X. So this is that second question. They want to know what Y is if they give you the X. So if 1998 is the year, we converted that using our system. X would be 8. So how do I find Y? Plug in X, plug in 8. So I'm going to do negative 0.16x times e squared plus 3.794 times 8 plus 28.314. Take it all in the calculator and tell me what you get. Make sure you guys are very careful over here with this first 8. 8 squared. You want to call it 24. Sorry, 64. Instead of 8 squared, that might be instead. You're putting it in. Yeah. Okay. So that's a regression question and then one example of each of the two application questions. Questions? No. Let's try another one. Totally different question. So we're going to go into our calculators. We're first going to find a quadratic model for this data. So we're going to go where? Stat, edit, enter your numbers. Alright, after stat edit, what do I do? Okay, so you go to y equals, you have 9. I've got this nice little quadratic shape. Then what? Stat calc 5. Okay. Y equals what? Yeah, right around 4. Squared. Minus. Because c is negative, you can throw a minus there. 182 plus. Everybody get that? Alright, next question. It says, use the model to predict the low temperature for the day. Say minimum. Again, low temperature. Asking for the minimum. And where do you find the minimum for a quadratic? The vertex. Now, which part of the vertex are they asking for? the x and the y. What? They're asking for the low temperature. X is always the first row or column, and y is always the second row or column. So the hours passed for x and temperature is y. So they're asking for the y value at the vertex. So this one's going to be a little bit more work than the previous question. You have to find x first, and then plug it in. So it's just like if you're trying to graph this, and I wanted to know what the y value was. So I still have to start with negative b over 2a, but then I'm going to have to use that value to plug it in. So my b was already negative, so it becomes positive. And then I multiply a times 2. Then you get 13.55. Right, so that 13.55 would be the hours passed. Is that what they were asking for? Were they asking for the x? Nope, they were asking for the y. So now you're going to plug that 13.55 into the function. Around 62.3. These application questions, I don't care how many decimal points you guys give me, as long as it's not a full number. Give me at least 1 or 2 decimals. Because in the model itself, you need to have a mixture. Alright, so about 62.3 degrees. See how we did that? Again, using the vertex idea. Alright, so the last one here. According to the model, what would the temperature be after 20 hours? So you're looking for y. Did they say, like, given that x is 20? Did they say find y given that x is 20? No, they kind of use the language that they use in the chart there. So that's why you have to convert it. The temperature, that's y. When you see hours passed, that's x. So the x value they gave you is 20, so you're going to plug 20 into this function and tell me what y is. Yes, yes. Make sure you guys are reading the questions carefully to know whether it's like a vertex question that affects the harmony, or it's going to be one of these where you're just plugging x in and y. Question? Alright, the last exercise I want to do is just visually. You don't need your calculator for this at all. I just want you guys to be able to visually determine if data is going to be quadratic. Okay? For quadratic, if it's like this, like a downward U, right? The data points for the y values increase, and then all of a sudden they decrease, right? To get that quadratic U, they would go up first and then down. If they're going to make that happy shape, they would go down and then up, right? So what I want you to do is look at this data set and see if you find that pattern. Do you see a rise and then a fall, or do you see a fall and then a rise? Either of those scenarios would give you a quadratic function. So all of the x and the x values do need to be in order, otherwise it's just zero. So you can see how all the x's are in order. So what's happening with the y's here? I'm rising, and then, well, here, not that way. And then say these points that are going up and they're going down. Does that make a U shape? Yes. So this one would be quadratic. And you can confirm that by using the zoom 9 thing, right? But you can also just visually understand how the points are going by doing. What about these? It has -2, -1, 3, 4, 6, 8, 9. They're all rising. What would that make? A line. That's not quadratic, that's linear. Alright, I have 4, 0, -1, -3, and then -2, 1, 3. So from these points to these points, what's happening? I'm going down, and then I start, my numbers start increasing again. So they decrease and then start increasing. When you have that switch, that's making your U shape. So this would be quadratic. What about these? Okay, so I'm going up and then down again. Right? So this would be quadratic as well. What about 7, 6, 5, 4, 0, -2, -3? Those are all decreasing. That's linear again. Okay? So you guys